is C8H7O2Br. It has 5 double bond equivalents. We have a 4H in the aromatic region between 7 and 8, that would be C6H4. We have a 3H over here, that's going to be 1CH3. And what do we have left over? We have a C, 2 O's, a Br and a double bond equivalent. That would be a Br, and then we would have a C double bond O and an oxygen. And you can see everything's counted down to 0, so there should be all the pieces there. The CH3 will go here, and you can see it's a single peak, which would indicate that it's next to something that doesn't have any hydrogens on it, and that could be the aromatic ring. Remember that the CH3 doesn't see these hydrogens here on the aromatic ring because they're too far away. It only sees hydrogens on adjacent carbon atoms. We have a C double bond O and an O over here and a Br. The Br is obviously going to go on the end, so I'm pretty confident about the placement of that, but I'm not sure where this C double bond O and the O are going to go yet. Now I can get some clues about that by looking at the placement of the CH3 group. As you can see, it lies between 2 and 3. It looks like we're going to be left with an ester grouping, a C double bond O connected to an oxygen. So we can take a look at what I've got here for that situation, and you'll see that in an ester situation, an O directly connected to a CH2, for example, will appear at about 4.0 ppm, whereas this CH3 directly connected to the C double bond O will appear between 2.0 and 2.5 ppm. The situation we have here is a CH3 that's between 2.0 and 2.5 ppm, which would indicate that it was next to probably the C double bond O group. The O then is most likely to go here, and the Br is most likely to go here. As far as the placement of the bromine and the aromatic ring, you might be asking, well, why couldn't we do something like this? Why not have the C double bond O over here and the O connected over here? I think that's kind of unlikely. First of all, because it's not a very easy compound to make, but secondly, because the placement of these groups in the aromatic ring are more suggestive of an activating group being connected directly to the aromatic ring and no deactivating group being connected to the aromatic ring. If we look at what we have over here, a C double bond O directly connected to the aromatic ring will usually split the ring into two sets of peaks centered at around 7.5 ppm. That's not the case here. The peaks are sort of too far upfield for that to be an occurrence. So I'm more inclined to leave the C double bond O here, place the O here, and put the Br on the end.